In the silence of the 1940s, the world held its breath. A secret project began, hidden under code names, guarded by science itself. It was called the Manhattan Project, a race against time, a race against fear, a race to control the power of the universe itself. Voice deepens, slow and mysterious. But what exactly were they trying to unlock? The answer lay deep within the atom, the invisible heart of all matter. Inside it, forces stronger than gravity, more powerful than fire, and capable of reshaping the world forever. This story begins with a single discovery: nuclear fission. In 1938, Otto Hahn and Lise Meitner found that when uranium-235 is bombarded with a neutron, the atom splits into two lighter nuclei, releasing an enormous amount of energy. That moment changed everything. It wasn't just chemistry, it was the physics of destruction. Einstein's famous equation, E = mc2, proved that even a small mass can release unimaginable energy. Scientists realized if they could control this chain reaction, they could build a weapon unlike any the world had ever seen. In 1942, under extreme secrecy, the United States launched the Manhattan Project, led by General Leslie Groves and scientifically directed by J. Robert Oppenheimer. The project united the brightest minds in physics: Enrico Fermi, Niels Bohr, Richard Feynman, Leo Szilard, Ernest Lawrence, and many more. They gathered at a hidden desert laboratory, Los Alamos. Their mission: to turn theoretical physics into the most powerful weapon ever created. But could humanity truly control the energy of a star? Let's understand the science. Nuclear fission happens when a heavy nucleus, like uranium-235 or plutonium-239, splits into smaller nuclei after absorbing a neutron. It releases energy, more neutrons, and a chain reaction begins. That's how an atomic bomb works. Each fission reaction releases about 200 MeV of energy, 1 billion times more powerful than a chemical explosion. But there's another force, even more powerful: nuclear fusion. Instead of splitting atoms, fusion joins light nuclei, like hydrogen, to form heavier ones, like helium. It's the reaction that powers the sun and all the stars. Fusion releases even more energy per unit mass than fission, but it needs extremely high temperatures and pressures, conditions found only inside stars, or hydrogen bombs. At Los Alamos, the physicists faced an impossible puzzle: how to achieve critical mass, how to trigger a controlled chain reaction, and how to make sure it doesn't fail. What if the bomb didn't work? What if it ignited the atmosphere? No one knew. Even the scientists feared the math could be wrong. Then came July 16, 1945. In the deserts of New Mexico, a new sun was about to rise. Codenamed Trinity, this was the world's first nuclear explosion. At 5:29 a.m., the desert turned into daylight. A massive fireball lifted into the sky, the birth cry of the atomic age. Oppenheimer whispered words from the Bhagavad Gita.
Says, "Now I am become death, the destroyer of worlds."
That single flash changed history. Within weeks, 2 bombs, Little Boy and Fat Man, fell on Hiroshima and Nagasaki. Hundreds of thousands perished. The war ended, and humanity entered a new age, an age where physics had rewritten destiny. But the Manhattan Project wasn't just a story of war. It was a story of discovery. It gave birth to nuclear energy, medical isotopes, and modern particle physics. Yet it also raised the deepest question of all: if knowledge can create worlds, can it also destroy them? From that moment, physicists began exploring not just fission, but fusion, the ultimate source of cosmic power. Today, scientists in facilities like ITER and CERN are chasing the dream of controlled fusion, to power the planet without destruction. The same science that once forged bombs could now light our future. The Manhattan Project was more than a secret mission. It was a turning point in human history. The atom had been split, the stars had been studied, and mankind learned that the greatest power in the universe comes with the greatest responsibility. We unlocked the power of creation itself. But the question remains, can we control it?